This is Scala Code, and understanding it is surprisingly easy. I know, you're asking yourself why should you even care? Well, it just happens that Scala is the perfect combination of OOP and functional with the right amount of type safety. Thanks to its expressive nature and mature ecosystem, Scala is used at companies like Twitter, Netflix or LinkedIn, and for the next few minutes you'll get a chance to see its main features in action. In a new .scala file, let's create an awesome object implementing the app trait. This is a convenient way of creating an executable program and has some delayed initialization benefits compared to the more conventional main method approach. Next, let's define a product class with a name and a price field. I am using the val keyword to mark the fields as immutable, since immutability is a big aspect of functional programming. Of course, once an object is created, you can't modify its fields directly, so you'll have to initialize another object in the heap if you need to update the data. The alternative is to use the var keyword, but without additional synchronization, you lose the thread safety. At the moment, we don't get any meaningful information when printing the product. So let's go ahead and define a toString method in our class. Note the following. We are overwriting the default toString method, we are using the new Scala 3 class notation to increase readability, and, thanks to this special notation, we can do string interpolation. We'll end up persisting products in a CSV file, and we can enforce this behavior by defining and extending a CSV trait. Finally, let's also create a helper method which will allow us to change the product price. Next, I am defining a function to retrieve a list of products from the disk. We'll open the CSV file, read the text lines, split the values based on the comma, and then convert the bits into entities. The file has to be closed, and the last expression in the function body will be returned. Of course, I/O operations can fail, and we have to use the try-catch construct to ensure our program will not throw an exception. While this code is self-explanatory, it is not really following Scala principles. Let me explain. Let's refactor the function like this and analyze it in more detail. The try object is a construct used to handle exceptions in a functional manner. It represents a computation that may either result in a success object wrapper or in a failure object associated with an exception. With fold, we can return an empty list on failure and perform our file reading on success. Quick side note, we can use the underscore notation to ignore unused values. Then, we are doing the same CSV line conversions. When we are splitting lines based on the comma, the result can either be an array of two values or something else. Pattern matching is a powerful expressive feature, especially in Scala, and we can use it to return the correct entity based on the matched value. Of course, the matched array will become some product, while any other format might be a corrupt entity, so we are going to ignore it. Because flat map is used, the sum and none values are flattened into an iterator, where all the none values are filtered out, leaving only the sum entities, which end up being the actual product instances. With the products available, we can now add a new instance in our list using the cons operator. Again, there is a lot to unpack in a single line of code. On one hand, immutability is the default in Scala, so we can't simply add a value to an existing list. Second, since the cons operator ends in a colon, it is right associative. That means that the method is actually part of the element on the right, which in this case is the list. Finally, in Scala, operators are just class methods, so this operation can be rewritten as this method call. Following the same notion, a simple addition in Scala can also be defined like this. Scala can be really expressive, powerful, and fun to work with, and there is a reason big companies are relying on it, especially in big data processing or for building concurrent distributed systems. Finally, let's write the products back to our file. The list of entities is mapped to a CSV line via lambda function, and note that since the CSV entry function doesn't accept any parameter, the parentheses can be completely omitted. If you find such coding overviews interesting, you'll probably like some of the other videos in this series. Until next time, thank you for watching.